Welcome to the CNC Orientation at Twin Cities Maker. Keep watching this video if you are interested in using any of our CNC routers. In this video, I'm going to give you a little tour of the shop. I'm going to go over how to get checked off. And lastly, I'm going to do a short demonstration of how to operate the Shapeoko and the XCarve. Keep in mind that this is not a comprehensive video of how to make something with a CNC machine from start to finish. That's just too much information to fit in one orientation video. But if you're totally new to CNC routers, I have added some links in the description below to some online videos that will help you to get started.
We're now entering the lathe and CNC room. When you enter, straight overhead, you'll see air cleaner, jet air cleaner. This is really good to use since this is an enclosed space and CNC routers tend to generate a lot of dust. To turn on the air cleaner, use the handheld remote. It's got an on-off switch. You can control the speed of the fan. And the time button will allow you to set the cleaner to run for a set duration, 2 hours, 4 hours. On the other side of the room, we have a dust collector for the lathes and also for the XCarve. And the switch is, turn it on, is way back here. The Maslow and the Shapeoko are not currently connected to a dust collector. On the left side, we have a Maslow vertical hanging CNC router. So it is suspended by these chains, which are driven by motors, which move the router left and right and up and down to make your cut. In this corner, we have some stock material you can use, some bits you can purchase, donation box, computer for the Shapeoko. Here are some community use bits you are free to use. The Shapeoko 2, which has an 11 by 11 cut area. If you're looking for something with a bigger cut area, then we've got this XCarve CNC router here with about a 30 by 30 cut area.
To get signed off to use the CNC routers, simply finish watching this video, check out the Shapeoko wiki page linked in the description below. You don't have to read the whole thing, but just be aware of where it is. Lastly, complete the online quiz, which is found in the Shapeoko wiki page.
This is the Shapeoko 2. Over here we have a control computer. It's got a couple of USB inputs if you want to load up your GCode files using a USB stick. This computer is also connected to the internet, so you could access your files through like a cloud drive, or you could email yourself the files. The bed of the machine has an array of 1/4 inch threaded nuts for clamping down your material using these setup clamps. Of course, you can also use something like double-sided tape to hold down your material. The router is a DeWalt DWP 611, which is pretty standard for machines of this type. When you're first using a machine, before you use the machine, it's a good idea always to move it slowly by hand to make sure that it is moving smoothly. And the reason for that is that these V-wheels tend to get clogged up with dust and then bind up. And when they bind up, you'll lose steps and ruin your cut. The power supply board for the stepper motors is over here. So if you want to, right now the stepper drives are not on. If I hit this switch, then the stepper drives are now on. Here you've got a Z probe that you can use for setting your Z0. Up there in that aluminum box is the controller itself, which is just Gerbil, GRBL, running on an Arduino. Oh, and also here on this aluminum block are some community use bits, so they're free to use, and if you have an extra bit that you want to donate, you can put it in one of these bit slots. We have 3 different sizes of collets: an 1/8 inch collet, a 6mm collet, and a 1/4 inch collet. So when you're buying a bit, you want to make sure that the shank of your bit fits one of these collets. To install a bit in the router, first you want to thread the collet into the router. Then insert your bit. So if you try to tighten it down, then the spindle is actually going to freely rotate. So you want to stop the spindle from rotating by hitting this spindle lock button. Once you've got it hand tight, you can go in with this 17mm wrench. Get it nice and snug. Here's how to clamp down your material using these aluminum setup clamps. So I've got one setup clamp already set up, and I'm going to do the rest. Start by threading this 1/4 inch threaded rod into where the 1/4 inch T-nut is. Adjust the thumb screw so that your clamp is sitting level with the bed. And take the thumb nut and thread it on the top of the threaded rod so that it presses down on the bar. Alright, I've got all of my clamps installed. The stock material is pretty securely fastened to the spoil board. You probably only need 2 clamps, but I did 4 just to make sure it's extra secure. I'm now going to turn on the machine, connect to the controller, and then home the machine. So first, to turn on the stepper drives, again, I just hit the switch on the step drive power supply box. And I have Universal GCode Sender open. The COM port should already be set to the correct COM port to connect to the Arduino. So I should have to just hit the connect button. Once it's connected, you'll see at the bottom left-hand corner there's an alarm. That alarm will go away after you've homed the machine or after you've hit the unlock button. You can hit the unlock button if, for whatever reason, you don't want to home the machine. But I'm going to go ahead and hit home machine, and there it goes. I'm now going to tell the machine where work 0 is. So when I designed my cam, I defined work 0 to be on the bottom left-hand corner and on the top surface of the stock material. This doesn't always have to be the case. You can use all kinds of different locations for work 0, but bottom left-hand corner and on the top surface is a really common location to use. To tell the machine that this location here is work 0, all you have to do is jog the bit to that location, and then in Universal G-Code Sender, reset your X, Y, and Z positions. So when they're reset, they'll all be set to 0. I'm going to go ahead and jog the machine to the work 0 position. A good way to tell if your bit is contacting the top surface of your stock material is to slide a piece of paper underneath it, and if it slides freely, you know that there's a gap and the bit is not in contact with the stock material. So I'm going to lower my Z until I feel some resistance. Okay, that's a little bit too far. I'll raise it up. All right, so that feels pretty good. I know now that my bit is at Z0. In Universal G-Code Sender, once your bit is at your 0 position, you can go into the machine drop-down menu, go to Actions, Reset 0. There's also an option to reset X0, reset Y0, reset Z0 if you want to 0 each of the axes separately. But I'm just going to go ahead and reset 0. So in the bottom left-hand corner, you can see that the X position is now 0, the Y position is 0, and the Z position is 0. Below each of these zeros is actually another X, Y, and Z coordinate, and those are machine coordinates. So those are relative to your absolute coordinate system, which was defined when you homed the machine. I also want to demonstrate how to use the Z-Touch probe. So we already used the sliding paper method for zeroing Z, but that method is kind of tedious. So using the Z-Touch probe is a lot more convenient. You want to clip the alligator clip to the bit. This bit is going to go down until it touches this aluminum plate. When it touches the aluminum plate, it's going to close this electrical loop, and the controller is going to sense that the bit has contacted the aluminum plate. In Universal G-Code Sender, you can go under Probe Module, hit the Z tab, enter in the touch plate thickness. So our touch plate is 15 millimeters thick. When we hit Initiate Probe, it should start going down until it touches the aluminum plate. Keep in mind that since this plate is 15 millimeters thick, we're sensing a plane that is 15 millimeters above the surface of the board. But that's okay because since we entered in that plate thickness in Universal G-Code Sender, when it senses the top of this aluminum plate, it'll know that your board is, or your stock material is 15 millimeters below that. I've got my material clamped down. I have my work 0 set. Now I can go ahead and go into Universal G-Code Sender, open up my G-code file. In this case, profile1.gcode. So this orientation doesn't cover how to generate a G-code file. To do that, you have to use a program like VCarPro or Fusion 360. And again, how to do that, you can look at the videos linked in the description below. So I've loaded up my G-code. Can turn on the router. And I'm going to hit the play button.
Okay, when you hit the play button, you want to be ready to immediately hit the stop button, just in case the machine doesn't do what you expect it to do. You might have set the wrong work 0 position, or your coordinate system might be off, or your feed rate could be way too fast. In any case, if the machine doesn't behave like you expect it to, hit the stop button and figure out what went wrong. One thing you especially want to avoid is crashing in the machine. A crash happens when the bit or the spindle tries to move through a solid object, like the clamps, or the bed of the machine, or its end stops. This can be especially damaging to the spindle bearings because the spindle wouldn't be able to handle the load. Or it could be damaging to the ways of the machine because a huge amount of torque would cause the V-wheels to flex. During your cut, if the controller bugs out, hitting the stop button in Universal G-Code Sender or easel might not have any effect at all. In that case, you'll have to shut off the drives manually and shut off the router as quickly as possible to minimize any damage. Back to the cut.
This is the finished product. I just cut out a rectangle. There is still a little bit of flashing remaining on the piece, and that's a result of not cutting all the way through the board. I might have had my Z height set a little bit too high, but that can be removed with some sandpaper or chisel. I also went ahead and cleaned up, vacuumed up all the dust on the bed, and I also made sure to vacuum up the rails on the y-axis and on the x-axis to make sure that these axes continue to move smoothly for the next user. The XCarve is very similar to the Shapeoko 2. There are a few differences. The array of threaded nuts Actually, these are threaded inserts, but this array of threaded inserts are metric. I believe they're M5, and they use these wooden setup clamps rather than the aluminum setup clamps. A nice feature of the XCarve is it has this suck-it dust boot. So if you turn on the dust collector back there and you open the gate, then there will be a vacuum sucking up all of the dust while you're performing a cut. So if you want to get to the collet back there, the dust shoe is attached magnetically, so all you have to do is give it a nice tug, and now you have access to the collet. Down here is where we keep some of the collets. So this is the 1/8 inch collet, the 6mm collet, and the 1/4 inch collet. Keep in mind the collets are shared between the XCarve and the Shapeoko. So if you can't find the collets here, you might have to do a little bit of scrounging around. The limit switches on the XCarve are a little bit finicky. They don't always work correctly. They sometimes false trigger. So I would recommend just not homing your machine when you're using the XCarve. The stepper drive switch for the XCarve is down here on this power distribution board. So right now the stepper motors are off. And if I hit that button, the stepper motors are now on.
Twin Cities Maker has a license for VCarPro Makerspace Edition, which is installed on both the XCarve and Shapeoko computers. VCarPro is a CAM software, which allows you to design the toolpaths that the cutter will follow to cut out your project. The nice thing about the Makerspace Edition is it allows you to do design work at home on your own computer, then come into the Makerspace to post-process your design, output a G-code file, and perform your cut. So the bulk of the work you can do at home and on your own computer. To follow this process, first you have to get the VCarPro Client Edition on your own computer. To get VCarPro Client Edition, go to Vectric's website and download and install VCarPro Trial. Once you have the trial version installed, you can convert it to the Client Edition. To convert your trial version into a Client Edition, go to the Help menu, click About, then click Enter Makerspace ID, and enter in our Makerspace ID. Our Makerspace ID can be found by going into the VCarPro Master Edition on the Shapeoko or XCarve, clicking Help, About, and clicking Get Makerspace ID. Once you've created your design in VCarPro Makerspace Client Edition and you've generated your toolpaths, normally you would go to Save Toolpath to post-process your design and to output your G-code file. But the VCarPro Client Edition doesn't actually allow you to do that. Only the VCarPro Master Edition has the ability to output G-code files. So when you've created your design, instead of outputting a G-code file, you'll just have to save your design as a VCarve file, bring it into the VCarPro Master Edition, and there you'll be able to output a G-code file. If you're looking for more information on how to get started with VCarPro, you can find a wealth of tutorials and videos on Vectric's website. Fusion 360 is another CAD CAM software you can use. It's really good at modeling 3D components, but it does take quite a bit longer to learn, and it's more geared towards design for manufacturing as opposed to wood carving, which is where VCarve really shines. Easel by Inventables is a browser-based CAD/CAM software that is very easy to use. It also has an integrated machine controller, so it's really an all-in-one CAD/CAM machine control package. It is by far the easiest software to use if you are brand new to CNC routers, but the free version at least is quite a bit more limited than VCarve Pro or Fusion 360. So that's it for the Twin Cities Maker CNC orientation. If you have any more questions, you can send an email to cnc@tcmaker.org. Or if you want direct communication with other members, you could post a message on the CNC Slack channel.